Right, so welcome to this lesson. So this is chemistry, and today we are going to focus on how to convert um, the number of molecules to atoms. Okay, or let's say we are given a certain mass of an element or certain number of moles of an element. Okay, how do we use that to convert to the number of molecules or to the number of what atoms? Okay, so the following are our objectives, these things that I've listed on your screen there. Okay, so um, we are going to look at how to convert the number of molecules to atoms as our first objective, and then our second objective is to convert any given mass or moles to the number of atoms or what molecules. So there are two methods that we are going to learn. Okay, there are two methods that we are going to learn. So the first method is what we call as the Avogadro's uh, approach. Okay, and then the other one is what we call as the atomic mass unit approach. Okay, so we can use either this approach or that approach to convert the given mass or the given moles to the number of atoms or to the number of what molecules. So this is our roadmap for this lesson here. So let's start with converting a number of molecules to atoms. So that one is the simplest there. Okay, that one is the simplest. Okay, so we know that molecules are just a group of atoms that are bonded together, right? Okay, and then we also know that a molecule can be represented in different ways. Okay, so one of the ways in which a molecule can be represented is in form of a chemical formula. Okay, in form of a chemical formula. So for example, if I write the chemical formula of carbon dioxide like that, okay, we see that this guy here is a molecule. Okay, and it's been represented in terms of a chemical formula. Okay, so given a specific molecule, okay, we can find out how many atoms that molecule has. Okay, so for example, this one molecule, okay, this one molecule of carbon dioxide has how many atoms? Okay, it has one atom of carbon and then plus two carbons of what? Oxygen. Okay, so we can say that in total one molecule of carbon dioxide has what? Three atoms. Okay, so one atom being of carbon, and then the other two being the atoms of what? Oxygen. Okay, so this relationship here uh, will be varying depending on the molecule that you have. Okay, will be varying depending on the molecule that you have. For example, if I have one molecule of carbon monoxide, okay, I would say this molecule here contains two atoms. Okay, because I can only see the oxygen there and the carbon. Okay, so what if I have a molecule of ammonia? Okay, so a molecule of ammonia is like this. Okay, so how many atoms does this ammonia have? Okay, we see it as one nitrogen plus three what? Hydrogens, like that. So it means the total number of atoms that it has is just four atoms, like that. Okay, so when you are converting the number of molecules to the number of atoms, it will depend, okay, upon the molecule that you are what? Using, or the molecule that you are dealing with. Okay, so let's give an example here. Okay, let's give an example of us trying to convert from molecule to atoms. Okay, so the example can be calculate. Okay, let me just write it down. Calculate the total number of atoms. Okay, the total number of atoms in 1.2 multiplied by 10 to the power 11 molecules, okay, molecules of carbon dioxide. Okay, so how can we calculate the answer here? Okay, so we're just going to use the ratio from the molecule. So we know that one more molecule of carbon dioxide, okay, is going to give us how many atoms? It's going to give us 3 atoms. Okay, so now what if we have 1.2 times 10 to the power 11 molecules of carbon dioxide? How many atoms are we going to have? Okay, so we are just going to do like a cross multiplication. So we are going to say one molecule is giving me 3 atoms. Okay, what about if I have 1.2 multiplied by 10 to the power 11 molecules? How many atoms am I going to have this side? Okay, and then you just cross multiply there. So it means you're going to have x is equals to this number here multiplied by 3. Okay, so it's going to give me a 3.6 multiplied by 10 to the power 11 what? Atoms. Okay, so that's how we can convert simply, okay, from the number of molecules that we are given to the number of what? Atoms. Okay, and then we can also do the same. We can be given the number of atoms and then we are asked to find the number of what? Molecules. So for example, let's give an example here where we are given the atoms and then we are asked to find the number of molecules. Okay, so let's give an example of that. So let's say you have 2.57 okay, atoms of H2O. Okay, so how many molecules will be in these atoms? Okay, so we are first of all going to get the ratio from this water. So we know that one molecule of water, okay, contains how many atoms? It contains 3 atoms as well. Okay, so we are going to do a ratio here. So 1 mole contains 3. Okay, what about if I have 2.57 atoms? Okay, what would be my number of what? Molecules. So you just cross multiply there. We are going to get 3x is equals to, then 1 multiplied by 2.57 to still be 2.57. Okay, so we are finding the x. So we are dividing both sides by what? By 3. So that 2.57 I mean, you just divide it by 3. So 2.57, let's divide it by 3. I'm going to get 0.85 and then 667 like that. Okay, so this here will be the number of molecules where you can find this number of atoms here. Okay, so in 0.85667 molecules of water, you are going to find 2.57 atoms of water. Okay, so that's the conversion that we can make there when you are given number of molecules to atoms or atoms to what? To molecules. So I'll move to the next one if there are no questions there. Okay, if there are any questions, feel free to ask. Okay, silence means there is no question. So I'll move on now to those two methods that we said of converting the mass to the number of atoms, okay, or the number of atoms to the mass. Okay, so let us look at this guy here. Let's look at this guy here. So we are saying convert mass or moles to number of atoms or molecules using the Avogadro's what? Approach. Okay, so what does this rule state? Okay, so this rule states that 1 mole of anything, okay, contains 6.23 multiplied by 10 to the power 23 particles. Okay, so that's what the Avogadro's approach states. So these particles here, okay, those particles can be they can be atoms, and then they can be molecules, okay, sometimes they can be electrons, okay, and then they can also be what? Ions. So these particles here, they can be atoms, molecules, electrons, or ions. Okay, so it doesn't matter what you're finding. Either you're finding the number of molecules, okay, you are still going to be using the same relationship that I've written down there. So 1 mole of anything contains 6.23 times 10 to the power 23 particles. Okay, and those particles to depend on the question that they they can ask you. Okay, to depend on the question that they will ask you. So now let's solve an example. Okay, let's solve an example here. So I'm going to erase this part here. Okay, I'm going to erase this part, then I'm going to write that ratio somewhere here. So as we said, 1 mole, okay, of anything contains 6.23 multiplied by 10 to the power 23 particles. And then these particles, we say they can be molecules, they can be atoms, they can be electrons, they can be ions. Okay, so now an example can say, okay, calculate the number of atoms. Okay, calculate number of atoms. Okay, calculate the number of atoms in 10 kilograms of copper. Okay, using the Avogadro's what approach. So how are we going to calculate the number of atoms in that 10 kg of copper? Okay, so the first thing is we have to convert the given mass. Okay, we have to convert this given mass here to moles. And then once we have the moles of this 10 kg here, we can use this relationship here. Okay, so let's convert this 10 kg of copper to moles. So the first thing there is to convert the 10 kg to what? To grams. Okay, so how do we convert the 10 kg to grams? Okay, so we have 10 kg and then we are trying to convert it to grams. We just replace this k with its value from the metric system. So we know that this k here is just the same as 10 to the power what? 3, or simply 1000. Okay, so we multiply this 10 by 1000. So it will be 10 multiplied by 1000. It will give us 10,000 what? Grams. So we have 10,000 grams of copper. Okay, so this 10,000 grams of copper, we're now going to convert it into moles. So we're going to say moles is going to be equals to 10,000 grams of this copper divided by the molar mass of copper. Okay, so you just go on the periodic table and then you get the molar mass of copper. Okay, so the molar mass of copper is about 63.55 okay grams per mole. Okay, so what when you divide this is that this gram and this gram is going to cancel and then you are going to remain with the mole. So what answer are we going to get if we do 10,000 divided by 63.55? Okay, so you just punch this on your calculator and then you divide by 63.55. So when we divide there, I'm getting this as my answer. So 157.356 moles. Okay, so I've rounded this to 6 significant figures. So these are the number of moles of copper that are in what? 10,000 grams, or that are in 10 kg of this what? Copper. Okay, so now that we have the moles, we can use this relationship here to find the number of what? Atoms. Okay, so let's free up some space here and then we can use that relationship. Okay, so now let's use that relationship. So we know that 1 mole is equivalent to 6.23 times 10 to the power 23 atoms. Okay, and then here we have this number of moles. So we have 157.356 is equals to x atoms. Okay, and then from here we're just going to cross multiply. Okay, so cross multiply, x multiplied by 1, you're going to get x. And then on the other side, we are going to have 15.356 multiplied by 6.23 multiplied by 10 to the power 23. Okay, so we just punch that value into the calculator to get the what? The final answer. Okay, so let me try to punch in that value to see the answer that I'm going to get. Okay, So that value multiplied by 6.23 is going to give me this value here. If I multiply by 6.23, it's giving me a 980.3304, and then this one here is still there, so multiplied by 10 to the power 23. Okay, so what you have to do now here is just to make um, this guy to be in scientific notation. Okay, so what do? We have to move that point here. So we move this point 2 times. Okay, so it should go between 9 and 8 there. Okay, so we've moved the decimal place to the right, so it means we have to subtract a 2 from this power here, because I mean we have to add a 2 to this power here because we are moving to the left. Okay, so we are going to say that our final answer is going to be, okay, so our final answer is going to be x is equals to 9.8. okay, we can just say 9.80 multiplied by 10 to the power 25 atoms. Okay, so these will be the atoms that will be in what? 10 kg of copper. Okay, so any questions there on how we are finding our answers there? Any questions? Okay, I'm happy if there are no questions. It means you guys are understanding. Okay, so we can actually use this same approach, okay, in case where we are given maybe we are given the number of atoms. Okay, let's say the same, we have maybe 2.67 times 10 to the power minus 3 atoms, okay, of, let's say, of hydrogen. Okay, we have this not let me not use hydrogen, let me say chlorine. Okay, let me say chlorine there. So maybe we have these atoms of chlorine, okay, and then you are asked to find the mass of this. So what do you think we should do? Okay, so what you should do is that first you convert this number of atoms to the moles. Okay, so we are going to use this ratio to convert to the moles. So we know that 1 mole is equals to 6.23, and then multiplied by 10 to the power 23 atoms, right? Okay, so if you have this number of atoms of chlorine, you're just going to add those atoms here. We're going to say 2.67 multiplied by 10 to the power minus 3 atoms. Okay, and then you say, what moles am I going to get? So you cross multiply. Okay, and then once you have your moles, okay, once you have your moles, you know that it's very easy for you to find the mass now. So if you have your moles, then it means mass will just be equals to the number of moles that you find here, okay, multiplied by the molar mass of chlorine from the periodic table. Okay, so you can do those conversions. Okay, I'm sure you're able to see them. Okay, so you can convert from the mass or the moles to the number of atoms or molecules. You can also convert from the number of atoms or molecules to the mass. Okay, so it's a two-by-way thing. You can do it either way. All right, so that's how you use the Avogadro's constant there. Okay, so any questions here before we go to the atomic mass unit approach? Okay, no questions. So I'll move forward to talk about how to convert, okay, from a given mass to the number of atoms or molecules using the atomic mass approach. Okay, so now when you come to the atomic mass approach, okay, it's very important for you to understand the units that you are given on your periodic table. Okay, so on that periodic table there, you can have an element like that. Okay, maybe you have oxygen here. Okay, so on top here you are going to have the number of protons that are in this element, and then down here you are going to have the molar mass. Okay, so 15.99, I don't know if there's 7 there. That's the molar mass of oxygen. Okay, but for our calculations we usually get what? 16. So Hello, let me mute them. Okay, so let's continue. So I was talking about the representation of elements on the periodic table. You have something like this. So that number on top represents the number of protons in that element. Okay, and then the number down represents the molar mass. Okay, the same molar mass that you know. So this molar mass here, what are the units for molar mass? Okay, so remember when we are solving questions on the isotopes, okay, we said the mass for the units for the molar mass are atomic mass unit. Okay, and this atomic mass unit is what you can see here, atomic mass unit approach. Okay, so what does the atomic mass unit approach states? Okay, it states this relationship. Okay, it states that if you have one atomic mass unit, okay, if you have one atomic mass unit, so this atomic mass unit can also be represented by just writing a U like that. Okay, so instead of you writing atomic mass unit, you can just write U. Okay, so one atomic mass unit, okay, so one atomic mass unit, okay, is equals to 1.661 multiplied by 10 to the power minus 24 grams. Okay, so this is the relationship that we are going to be using in this approach. Okay, we have to know that one atomic mass unit, or simply you can just say 1U, is equivalent to 1.661 times 10 to the power 24 grams. Okay, so that's the 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 equation that we are going to be using here. Okay, so one atomic mass unit is just equals to whatever we have here. So when you go on the periodic table there and then you get one atom of oxygen, okay, so if you get one atom of oxygen, this one atom of oxygen, how many atomic mass units, okay, is it going to have, or what is its molar mass in short? So one atom of oxygen has a molar mass of what? That same 15.997 atomic mass unit, which is the same as U. Okay, so if you have one atom of oxygen, you have these atomic mass units. Okay, so now you can get this atomic mass unit and then use this relationship here to find its mass. Okay, so you've moved from the number of atoms to the atomic mass unit to the mass there. Okay, so even the vice versa is also true. You can move from the mass that you are given, okay, you use that mass to find the atomic mass unit, and then after you find the atomic mass unit, you use it to find the number of atoms for that specific element. Okay, so this is the approach that we are going to be using under the atomic mass what unit approach. All right, so now let's solve an example. Okay, let's solve an example here. So I'll rewrite that relationship somewhere because we'll be using it. Okay, so let me pick red here. So I'll write it on top here. So one atomic mass unit, which I'll just write as 1U, is equals to 1.661 multiplied by 10 to the power minus 24 grams. Okay, so I'm going to get the same question that we did on the Avogadro's constant. Okay, I'm going to put it here so that we convert it using the atomic mass unit approach, and then we see if we are going to get the same answer. Okay, so let's convert, okay, or find the number of atoms, okay, in 10 kg of copper. Okay, so now we are using the atomic mass unit. Okay, so what we have to do here, or the two relationships that we are going to use are one atomic mass unit is the same as 1.661 times 10 to the power minus 24 grams. And then the other one, since we are dealing with copper, okay, so we know that one atom of copper, okay, has, what is the molar mass of copper? Okay, so the molar mass of copper from the previous question, we said it was just 63.55, right? Okay, that's what we said. So I'm going to write 63.55 U here. So this U here, I said, is the same as atomic mass unit. Okay, so these are the two relationships that we are going to use in order to answer our questions. Okay, so now let's solve. Okay, so we have 10 kg here. So the first thing is always to remove this from 10 kg to the grams. Okay, so we know that 10 kg from the previous question is just the same at you write 10,000 what grams. Okay, so let's convert these grams to the atomic mass unit. So we are using this first relationship there. Okay, so I'm going to write 1 atomic mass unit is simply equals to 1.661 multiplied by 10 to the power minus 24 grams. Okay, so what if now I have 10,000 grams? Okay, how many atomic mass units am I going to have there? Okay, so you cross multiply, so it means you are going to have what? X multiplied by this number, okay, and then equals to 10,000. So it means our X will just be simply equals to, we have our 10,000 there, and then we are dividing it by 1.661 times 10, okay, to the power times 10 to the power minus 24. So what are you going to get there? Okay, so let's punch that into our calculators. Okay, let's punch that into our calculators. So okay, so I have, let me open the scientific calculator. Okay, so I have 10,000 divided by 1.661 multiplied by 10 to the power minus 24. Okay, so according to my calculator, I'm getting this value. I'm getting 6.0204. I'll round it off to here. I'll round it off to 7. There was a 6 here. I'll round it off to 7. Then times 10 to the power 27. These now will be what? Atomic mass units. Okay, so we've converted this mass here in grams. We've converted it to what? To atomic mass units. Okay, and then now we can use these atomic mass units that we get here to find the number of what? Atoms, using this relationship here. Okay, so let's do that. Okay, so now using that other relationship that we've been given, we know that one atom, okay, is the same as 6.55 units, okay, of this copper. So now we are going to write these atomic mass units that we have, 6.02047 times 10 to the power 27 units. Okay, so this was a 27 here. Alright, and then we are going to say X. Okay, so the next thing there is just to cross multiply. So cross multiply, what are we going to have? Okay, as our number of atoms. Okay, so when we cross multiply there, we are going to have X is equals to, okay, 6.02047 multiplied by 10 to the power 27, and then divided by 63.55. Okay, so we just have to punch whatever we have here on our calculator. Okay, so let's do that. So okay, so that number there, the 6 point whatever we have there, I'm going to divide it by 63.55. Okay, so I'm going to get approximately 9.0 7 4 3 5 times 10 to the power 25 there. Okay, so these are the number of atoms in what, in copper. Okay, so you can see that it's similar to the number of atoms that we found using the Avogadro's constant. So if I can go back here, what did we find here? We found this number here. Okay, so that was 9.80 and then 10 to the power 22. We see that it's close to that same number. This is 9.7 times 10 to the power 25 atoms. Okay, so we can use any of those approaches to find the number of atoms and molecules, but sometimes in questions they do specify. Okay, they ask you use the atomic mass approach in this question, or use the Avogadro's what approach. Okay, so you have to know both of those approaches there. Okay, so any questions on how we can do these things here? Any questions? All right, so if there are no questions, then that's the end of this lesson. Okay, I've taught you how to convert from molecules to atoms, and then convert from mass to the number of atoms or molecules using the Avogadro's constant, and then also using the what, the atomic mass unit. Okay, so I have an assignment here for you, so try it out. Okay, so there are 3 questions. They are very simple questions. Just follow the same steps that I was given in the lesson. Okay, so this is the assignment here. Make sure you try it out, and then you get to learn these things. Okay, so any other question before we end the class? Okay, so if there are no any other questions, then have a blessed night, guys, and thank you for attending the class. Continue learning until you reach your destination.